I'm 11th grade class 6 Yeonju, and I'm going to present the symmetry and the probability of Isan's poet quantum matrix. Let's take a look of the table of contents. First of all, I'm going to talk about who is Isan, and next I'm going to talk about the matrix and the transpose of a matrix. And finally, I'll apply the poet. Then let's get started. First, who is Isan? He born at 1910 and he died at 1937. He graduated Gyeongsang High School, which is now Seoul University of Engineering, and he graduated with honors. Also, he published poems with full engineering knowledge, so it is possible that he utilized the transposition matrix concept to imply an antimetrical image, which is one of the quantum mechanical features of his poem. And the matrix is a set of numbers arranged in rows and columns so as to form a rectangular array. And the transpose of a matrix is simply a flipped version of the original matrix. So we can transpose a matrix by switching its rows with its columns. Then let's apply to poetry. In the figure above, this is the famous Heisenberg matrix mechanics expression, and that one is the matrix notation from the text above. You can see the dotted rectangle I marked inside the matrix mechanical expression. You can see the similarity between the matrix equation and that square and the 3x3 matrix of the anomaly text on the left, as already mentioned. If you look at the black dots in the rear text as each element of the matrix and give each element coordinate along the rows and columns, we get part of the matrix mechanics expression. As mentioned, the matrix mechanics expression represents the probability of an electron being located at each row and column coordinate, which can be interpreted as a specific entity of an event cause and that entity. In above image, we see a pair of 3x3 matrix with 3 horizontal rows and 3 vertical columns. The first matrix is a matrix with 1 and 2, 3 rows and 1 to 3 columns. And the second matrix is a matrix with 3 to 1 rows and 3 to 1 columns. Each element is both matrix is a dot, a quantum image of the universe. See table 1 below if you perform an operation between each element in the matrix. In the case of addition, the element 2, 4, 6 and 6, 4, 2 on the right downward diagonal axis and are inverted from each other, and each element is inverted from the transpose matrix position to 3 and 4, 4 and 5, 5 and 5, 5, 4, 4, 3, 3. And in the case of multiplication, as will be explained below, the same is true for 2, 2, 3, 3, 6, 6, and 6, 6, 3, 3, and 2, 2. Consider the subtraction between the two matrices. First, for A and B, the vertical rows are subtracted from the horizontal columns, and for C and D, the reverse is true. The vertical columns are subtracted from the horizontal rows. As you can see, we have 4 matrix operations, and in all of them we find transpose matrix. A transpose matrix in which the values of the elements facing each other, such as dotted lines, are inverted with negative and positive signs relative to a diagonal reference element 0, 0, 0. In his poem, the self reflected in the mirror has an elemental image with a negative sign of the transposition matrix, and the diagonal line 0, 0, 0 can be interpreted as symbolizing the boundary between the real and imaginary worlds, the sharp boundary between the real and the mirror world. Let's look at the case of addition and multiplication. In the case of addition, the diagonal axes are 2, 4, 6 and 6, 4, 2 when looking at the two matrices. For multiplication, the diagonal axes are 1, 4, 9 and 9, 4, 1. Respectively, in this case, the element values with the same positive sign across the inverted diagonal axis are 3,3, 4,4, 5,5 for addition, and 5,5, 4,4, 3,3 for multiplication. The transposition matrix that appeared only in the case of subtraction, where the elements with the same diagonal axis 0, 0, 0 and symmetry were opposite signs, such as 1, minus 1, 2, minus 2, and 1, minus 1 respectively, as in the case of A. How do we explain the opposite case of addition and multiplication? Perhaps this is because the diagonal axis is inverted, and the same signs 3,3, 4,4, 5,5 for addition, and 5,5, 4,4, 3,3 for multiplication are the same sign, but they are considered symmetrical for each other. In this case, it is natural to assume that each symmetry is a pair of complex numbers and symbolize the relationship between matter and antimatter in quantum mechanics. Patterns, the quantum of light, are each dot, and their mutual energy balance shows that a network, a quantum entanglement, is formed between matter and antimatter. For example, if the quantum spin values of one is half clockwise and the quantum spin value of the other is minus half counterclockwise, this is because the energy values between the two universes converge to zero as the respective energy and momentum cancels out. This contains allusions to the depths inherent in the existence to parallel universe and multiverse, where multiple universes may exist, divided by choice and light and shade. When two substances come into contact, they emit a gamma ray-like light that dissipates, and so the tensions between the two cells in and out of the mirror in the ideal mirror is a precursor of a convergence to zero. The gamma ray, for the language of poetry, hovers at the sharpest edge of existence. Next, let's pay attention to the coordinate values of each element instead of row and column operations. Check the coordinate values specified that page. Next, draw an axis diagonally to right and down, and you will see the symmetries bounded by the drawn axis. Notice the symmetries of 2, 1 and 1, 2, 3, 1 and 1, 3, 3, 2 and 2, 3 in the matrix. A matrix and 2, 3 and 3, 2, 1, 3 and 3, 1, and 1, 2 and 2, 1 in the B matrix. Since the structure is a transpose matrix with horizontal rows and vertical columns inverted, let's represent each of X 6 symmetries points out on the following first-order function diagram. What I prepared is this is it. Thank you for listening.